Hi. In a previous video, I talked about atoms and molecules and the periodic table, and I mentioned how the most important subatomic particle of an atom in terms of chemical bonding are electrons. And so in this video, I'm going to talk about the different types of chemical bonds and how they form. There are three major types of chemical bonds: ionic bonds, covalent bonds, and hydrogen bonds. And we're going to start with ionic bonds. So an ionic bond is whenever electrons are transferred between atoms. And a great example of an ionic bond, especially if you're in a biology or an anatomy and physiology class, is sodium chloride. So if we look back at the periodic table, we will see that sodium has 11 electrons and chlorine has 17 electrons. So let's draw that. So sodium is going to have 2 in this first shell, 8 in the second shell. So 2 plus 8 is 10, so it's going to have 1 more in that third shell. So again, atoms need 8 electrons in their outer shell to be stable. Chlorine is going to have 2, 8, and 7. So sodium needs 7 more electrons to be stable. Chlorine needs 1 more electron to be stable. And so the easiest way to make both of these atoms stable is to transfer this electron from sodium to chlorine. That's going to eliminate this outer ring for sodium. So now the second ring has 8 electrons, and then chlorine in the third outer ring has 8 electrons. And so in order to be stable, the atoms sodium and chlorine bind together and form a chemical bond, an ionic bond, to create the molecule sodium chloride. Another major type of chemical bond are covalent bonds. In a covalent bond, electrons are shared between atoms. So rather than electrons being transferred from one atom to the next, those electrons are now going to orbit around multiple atoms. And one example of a covalent bond is O2. So this is the oxygen that we breathe. So if we look back at the periodic table, oxygen has 8 electrons. So that means it's going to have 2 electrons in its first shell and 6 electrons in its second shell. So then we're going to draw another atom of oxygen. So in order for these 2 atoms of oxygen to be stable, they have to share 2 electrons, because this atom needs 2 electrons and this atom needs 2 electrons. And so this, maybe one of the electrons or 2 of the electrons will end up orbiting around this one, and 2 of these electrons will end up orbiting around this one as well. And so those electrons will orbit around both atoms. Another great example of this of a covalent bond is water. So water is H2O. So again, oxygen is going to have 8 electrons, so it's going to have 6 in its outer shell. Hydrogen, on the other hand, has 1 electron. So since there are 2 hydrogen atoms and they each have 1 electron, this 1 electron can be shared with oxygen in order to make everything in this molecule stable. There are 2 types of covalent bonds, polar and nonpolar covalent bonds. In nonpolar covalent bonds, electrons are shared equally. And a great example of this is O2, what we just talked about. Carbon dioxide is another one. Water, however, is a great example of a polar covalent bond. And in polar covalent bonds, the electrons are shared unequally. And how electrons are shared depends on the atomic weight, so the mass of the atoms. So if we look back at the periodic table, hydrogen has a mass of about 1, and oxygen has a mass of about 16. So that's a pretty big difference in mass. And again, you can think of atoms like little planets. The bigger the mass, the more gravity, more gravitational pull they're going to have. And so even though oxygen and hydrogen are going to share these electrons, the oxygen atom is going to pull those electrons, bring those electrons closer to it more often. So those electrons are going to end up spending more time around the oxygen atom compared to the hydrogen atom. This unequal sharing of electrons creates a very interesting molecule. So since electrons are negative, if electrons spend more time around the oxygen atom, that's going to make that oxygen region more negative compared to the hydrogen region. Just like if you spend time around people who are negative, you're going to become more negative. So this is the reason why atoms that are creating a polar covalent bond are called polar, because they end up creating a polar molecule. So when we say pole, we mean opposite ends. Just like a battery has a negative and a positive end, or poles, a water molecule is going to have a negative and positive end, or poles. Nonpolar molecules, however, since they are sharing those electrons equally, they are not going to have any charges. The electrons are not going to spend more time around one atom versus the other, and so there's no negative or positive region. So those polar covalent bonds then can lead to what we call a hydrogen bond. hydrogen bonds aren't really bonds in the sense that electrons aren't being shared or transferred. It's just an interaction between atoms. And I don't mean that in an insignificant way. Even though there's no sharing or transferring of electrons, hydrogen bonds are or can be very strong, and they're also very significant. So let's take water as an example. A body of water is going to be made up of several water molecules. And again, the oxygen region is going to be slightly negative compared to the hydrogen region, which is going to be slightly positive. So we know that negative and positive charges attract to each other. And so the negative region of one water molecule is attracted to the positive region of another water molecule. That attraction is called a hydrogen bond. So hydrogen bonds occur between water molecules, or between molecules in general, whereas polar covalent bonds occur within a molecule. Thanks.